Nice to see you.
Blinken,
How are
nice to
you?
meet you.
Good to see you.
Good to see you. Yes, my name is Nick Bentley. I actually work here at the University of Maryland. Currently pursuing a master's degree. Actually, collaborating architecture, and I help out with Terrapin Works operation. Yep, this is my counterpart.
So I'm Chinmay. I just graduated as a space.
Congratulations.
Thank you. And I'm just back to make sure our brand new machine is all in working order before I leave.
That sounds like a good idea.
Yeah.
So, all right, I'll go ahead and kind of kick this off. I'm just going to give you the spiel about what Terrapin Works is, kind of what it means to a large school and university as a whole. Terrapin Works was kind of founded right back around 2014, back in the 1990s. Kind of put out a solicitation for kind of what was going to be the next big thing in engineering. And one of the big proposals we put forward was like, why don't we do something in additive manufacturing? So fast forward, a couple of years, we go through some procurement processes and buy a bunch of 3D printing equipment, additive manufacturing machines, and we end up with some pretty awesome spaces. Started over in a different building where it was kind of like hole in the wall type thing. Didn't really had to kind of know where to get. But the nice thing about that was that it was co-located next to a student-run incubator space called Startup Shop. We like to foster a big entrepreneurial ecosystem on campus. And there was kind of a really nice interaction and synergy that occurred between the Terrapin Works operation and the Startup Shell. Students would come in, they could learn how to prototype, part for something for a startup, and then go from actual part in the lab to starting business happening. So yeah.
And does that happen on a regular basis?
Yes. So we actually had, back when I used to run the Startup Shell as part of my undergraduate career here, we actually had a couple of students, one in particular that used the resources that Terrapin Works provided to build his own 3D printer called ReadyBox. He actually exited and sold it to a larger company, and actually at the time was marketed as the fastest consumer 3D printer, which was a pretty cool experience.
And how did you decide on the focus on 3D printing?
The use case for 3D printing was that it was an emerging technology at the time. So in 2014, Stratasys had come out with some of their very early on machines, and they were big infused deposition modeling technology. Since that was emerging technology at the time, we decided, okay, well, 3D printing is kind of the way to go. There was some early other stuff in polyjet process, which we'll explain once we go through the lab. We have kind of one printer we can show you here. As we have kind of fast forwarded through the years, we've actually continued to invest in new technologies and grow the operation. We moved over to Clark Hall recently in the last couple of years. That's the space you're in right now. And that's actually probably a good time to get right over to Chinmay and talk to you about the various functions of the space.
So this is the Advanced Fabrication Lab. Really, when we set out and got this lab, we wanted to kit it out with everything that would enable someone at Startup Shell, for example, to come into the space with any idea for a product or some sort of invention that will help people, and really walk out with something that's functional. They can show to investors. They can even use a couple of them to test in real-world applications. So really, you'll see kind of as we walk through all the spaces that we have the tools from beginning to end of the design process. So that really helps anyone that walks in. Like we said, startups, but also students that walk in, student competition groups, researchers. We kind of help everyone, and we want to make sure that everyone has the tools that they need to do whatever they want to do. So really, starting over here, we're starting with the first stage of the design process. So here we have kind of our scanning area. This is actually a 6-axis scanning arm with a laser head scanner on it. What's cool about it is this is like real-world technology that people use in the industry. So, for example, this exact scanning arm is actually the one that F1 teams will use to inspect the carbon fiber bodies of their cars. And what's cool is that students can come in, they can either be staff members or they can even just walk in, be a part of, be a student at UMD, and they can use this equipment. So it makes it very accessible for all these people. What's cool about scanning technology is it really allows you to do certain things that you're not easily able to do kind of by hand on a computer. Let's say you want to make a very organic shape, something that interacts with someone's hands or something like that. You could mold it out of clay, and then you could scan it in, and then you can have that then you can play around with it and really integrate it into whatever you're trying to build. So this is really a great tool to make functional parts. Kind of stepping a little bit further into the space, now we're walking into where our workstations are. These are all high-power workstations with all the software that you would need to really take whatever you're starting with, whether it's just a 2D image or hand sketch or whatever, and then go to a final functional design. So all the design software you would ever need is on here. We will step in a little bit further. So really the idea is that everyone will be able to walk into the space, whether they're a student, and they can just use these computers, hop on, get going, whatever they need to do. Then we will try and step through here a little bit. Right here you kind of have our first big machine. This is actually one of the first polyjet machines that we ever had at Terrapin Works. It has been resurrected. There was a period of time where it wasn't working at all. We have a donor machine down there, but we got it back up and running, and now we're running some test prints in there if you just want to take a look real quick. So I'll explain this technology a little bit later, but it's very interesting, has some really nice use cases. Alright, so then back in this corner, we really just have a bunch of different consumer-grade 3D printers. This is something that you would see kind of in someone's basement if they were doing stuff on their own. Really what we want to do here is provide kind of low-cost prototyping for people. So they've done their kind of rough design. Now they want to see like a physical model of whatever they're designing. They want to see like kind of what the problems are, what they need to change. Right?
So if I had a printer at home, what is a practical matter might I be, using it for? What would a consumer do?
A consumer can do a lot of things, right? Like it can go from simple things like desk trinkets or like little brackets to hold things together, all the way up through, like we've seen hobbyists will come in and they'll want to print like a mold of, actually we had someone who wanted to print a baby's foot. They wanted to basically have this real model of a baby's foot that they could mold out of silicone and then play around with it, because they were trying to build a device that would massage the bottom of babies' feet when they were in critical care, so that they would feel that touch and hopefully recover faster. So that's like one of the things that you can do with just like a consumer 3D printer. Very low cost, very quick. But we'll get to the things that the industrial machines are kind of better at. So Nico, if you want to talk really quickly about what you're doing here.
Oh yeah, so this is SLA, and so it's a resin-based 3D printing technology. And right here, someone, I guess, printed a little model of a guy. But it has a much higher resolution than some of these consumer-grade 3D printers, and so you're able to get a little higher, finer detail. And also, this object is fully solid all the way through.
So how long did it take to produce this?
I think this was a couple hours. We started this morning.
Yeah, this is about 3 hours. So you can see like this has an amazing surface finish right here. There's text engraved right there. And it's a completely solid part. So you can do some nicer things with, these are kind of more expensive consumer grade machines.
Right,
And then,
hop on over to the next part of
Yep.
Go ahead and
We'll just step in a little bit further. Alright. So right here, kind of in this front area, we have a lot of electronics prototyping equipment. So we've done kind of the design, the physical prototyping iteration, that all kind of happens in the front room. Now we have the electronics prototyping, so we want to be able to build the things that go inside whatever your product is. So really, we have all of the tools you need to make a fully functional PCB that goes in whatever product it is. So Nathan, do you want to talk real quick about that?
How are you?
I'm good. How are you? So right now I'm designing a PCB to, I haven't gotten super far on it yet, but it's going to decode some inputs into like a display. And so as soon as I'm finished with designing this, it's going to go onto that mill, and you can see the copper sheet in there. That's how the PCB starts. and then you do some chemical processes to it, and then at the end, you get a result that should look something like this. So these machines are super nice. Like this is the same process they use at the professional, like large scale operations, and we can just do that here for anyone who wants to get PCB made. You can hold it.
All right. We're gonna step around to the other room.
So we're gonna head out the,
Out
the back
Head out the back door.
All the way out.
all the way out the back door and around and the other way.
I'll turn around.
So, stuff right in here is this machine is actually doing a very large print right now. This is similar technology to what we saw out here on the B-Flat platform. This is polyjet technology. What it does is it's basically laying down resin in stripes across this building and then curing it. But what's cool is that you can actually mix different types of resin. So you can have resins that are of different flexibilities. So that white one will be very hard, and this black one will be very soft. And they can be printed on the same build plate at the same time.
This printer is super popular with our researchers because they can do a lot of kind of like medicine technology and stuff with it. One of the things that's playing right now is, I don't know if you saw in the news, there was like a Nintendo. It played Nintendo. This is
That was printed here.
Wow.
So you can actually these guys
They articulate.
yeah, and it uses air. That's the mechanism to actually articulate.
Yep.
Came off this machine.
Yes, sir. Good.
Alright.
Alright, so we're gonna step into the desktop metal area. Garrett's gonna talk to you about desktop metal, our brand new metal 3D printer.
Yeah,
Yep.
so this is really the cutting edge right here.
Hey, how are you?
So Gary, you want to talk really quickly about that?
Sure. So these parts, the material comes in a stainless steel powder, and they are printed over here using binder jet material. So the print head goes across and it lays down the binder for the two-dimensional shape of whatever you're printing. Here's a better image on here. And then the coater comes back across, lays another layer of powder, and then this just happens back and forth. So you have the right number of layers. So this total job is 662 layers. It's taken about 4 hours to print. So after they're printed, we take them out of here and we put them into our curing oven. And this runs for about 24 hours. We pull that out. We de-powder the parts, so we take off any excess powder. And then the parts are put into our sintering oven where they sit for about another 48 hours.
And then you end up with a solid stainless steel part like this. And you can see how this geometry might be a little bit challenging to do through any other means. But with 3D printing, it's all self-supporting. And you can print this shape very, very quickly. So, yeah. So this gets up to 1400 degrees Celsius. Yeah, very hot.
All right.
All right.
Our mascot, we've been allowed to. It is somewhat challenging. It really depends on the type, on the machine. Some of them have more stringent maintenance procedures than other ones. Conex is pretty stringent, has like daily maintenance that you have to go through. Some of the ones before this will explain to you.
Hey, how you doing?
Yeah, how you doing? So this is the Fortus. This is a very large FDM printer, so it's kind of like one you saw in Workspace. What's nice about this is obviously it's much larger than the other printers, but we also print in a variety of materials that aren't offered on typical FDM printers. So some of them would be like PPSF or Ultem, which are very heat resistant. So they come with like a lot of good applications for aerospace and whatnot. And we just finished part right now. And I think this is going to be used for drying ovens over there. It's very sturdy.
One of the nice things about working in a 3D printing lab is that when you need a part,
You can actually make it yourself.
Yeah.
Very good for
So next thing I'm going to talk about is this machine back here, which is the HP Multi-Jet Fusion 580. So we actually made for you guys
That's
the
great.
Department of State seal. So
Great.
it's actually very interesting. It's a little stand that
Yeah.
you can put on your desk.
Oh, that's great.
And what's cool about it is this part right here was actually generatively designed. So this was actually made on the computer. I basically told it that it's going to have a certain load applied to it, and the computer decided that this is the most effective
This is the
place to
optimal.
put the material. So this is one of those applications of additive manufacturing that you really can't do with subtractive, or at least it's much
And one of
harder.
the cool things about generative design is it's really applicable to infrastructure. So new bridge designs are actually generative design is being used in some of the bridge designs.
Yeah, and then this is pretty much how it came off the printer.
That's
We
great.
actually just pulled these off this morning.
Terrific. Thank
Yeah,
you.
in full color.
Let's see.
Another benefit of additive manufacturing.
That's great.
It's pretty much hollow inside.
And we expect that'll be displayed on your desk.
Oh, absolutely. We'll make sure. And I'll send you the photographic evidence.
Great.
Thank you very much.
You're very welcome.
Greatly appreciate it.